October 11th, 1941, for 15 in the afternoon, on the muddy road to Tula near Mtsensk, a German panzer crew stares in silence at a nightmare they were told could not exist. Smoke curls off a shattered Panzer III, its turret torn open like a tin can. Rain hisses against hot metal. The air reeks of diesel, scorched paint, and wet earth churned to black soup by treads and boots. Somewhere close, a wounded engine ticks as it cools, and a few hundred meters away, half swallowed by mud, sits the machine responsible, low, sloped, alien in shape. The Germans have only just learned its name, T-34. This is not a rumor whispered along the front. This is wreckage. This is proof. For months, German intelligence had dismissed Soviet armor as crude and outdated. Commanders trusted their Panzer IIIs and IVs, their superior radios, their battle-tested tactics. Then Operation Barbarossa began, and something strange started showing up in after-action reports. Soviet tanks were taking direct hits and surviving. Shells that shredded French and British armor were skidding off this new machine's sloped steel and vanishing into the dirt. General Heinz Guderian, commanding 2nd Panzer Group, had read those reports through the summer with growing unease. But here, near Mtsensk in October, Soviet tank brigades under Mikhail Katakov slammed into his spearhead and shattered the illusion completely. Guderian later described the shock spreading through his officers, a cold, sudden understanding that German tank supremacy, unquestioned since the fall of France, might already be gone. What made this machine different? Why did rounds that killed everywhere else simply bounce here? The answer sat right there in the mud, waiting. German engineers wanted it dragged back for study. Guderian wanted answers before another column got cut apart the same way. And in Berlin, the machinery of response was already turning. A commission of officers and industrial engineers being assembled, ready to travel east, kneel beside a captured T-34 and run bare hands over its armor plate. What they would find in the weeks that followed wouldn't just alarm them. It would humble them. And it would force Daimler-Benz, MAN, and the German War Ministry into a crash program that changed the entire trajectory of armored warfare. The birth of a tank called Panther, built not out of confidence, but out of fear. By late November 1941, the captured T-34 had been dragged out of the frozen mud and loaded for transport west. German engineers had requested an intact specimen for months. Now they finally had one, and the men sent to examine it were not ordinary soldiers. They were some of the best minds in German industry, engineers from Daimler-Benz, MAN, and Krupp, along with ordnance officers who had spent years studying armor design. What they found unsettled them immediately. The T-34's armor was sloped at roughly 60 degrees on the hull front. German tanks used mostly vertical plates, easier to manufacture, but far weaker against incoming rounds. Sloped armor did something deceptively simple, yet devastating. It increased the effective thickness a shell had to punch through, and it dramatically raised the odds of a deflection. A shell that should have killed the crew instead skipped off into open air. Then there was the engine. The T-34 ran on a diesel power plant, the V-2, which was far less prone to catching fire than the gasoline engines used in German tanks. For crews who had watched their own machines erupt into flame after a single penetrating hit, this detail alone was chilling. And the tracks, wide, rugged, built for the endless mud and snow of the Eastern Front. German tanks, designed with European roads in mind, sank and slowed in the same terrain the T-34 crossed with relative ease. Guderian, who had personally pushed for this technical investigation, reportedly urged an extraordinary solution. Copy the T-34 outright, license its manufacture, and get it into German hands as fast as possible. It was a suggestion that reportedly did not sit well within Berlin's engineering establishment. Pride played a role. So did practical concerns. German production lines, tooling, and metallurgy were not easily adapted to Soviet designs. Instead, a special commission was formed in late 1941, tasked not with copying the T-34, but with designing a new German tank that could match its strengths while fitting German industrial capabilities. Daimler-Benz and MAN were both instructed to submit competing designs. Daimler-Benz, in fact, initially proposed something startlingly close to a direct T-34 copy, sloped armor, similar hull shape, even a diesel engine under consideration. For a brief moment, Germany came remarkably close to fielding something that looked almost Soviet in silhouette. But the design that would ultimately be chosen, the one submitted by man, would take those Soviet lessons and filter them through German engineering philosophy, precision optics, complex transmission systems, higher velocity guns. It would be given a name meant to evoke stealth and lethal power. The Panther, and its road to the battlefield was about to become far more complicated and far more dangerous than anyone in that design commission could have predicted. Through the winter of 1941 into 1942, the pressure on German designers only intensified. Hitler himself took a personal interest in the Panther program, pushing for heavier armor and a more powerful gun than the original man design called for. Engineers worked under brutal deadlines, racing to get a combat-ready tank into production before the next major Eastern Front offensive. The result was a machine that, on paper, looked formidable. The Panther's sloped, glassy plate, clearly inspired by the T-34, was even thicker than its Soviet counterpart. Its long-barreled 75mm gun could punch through enemy armor at ranges Soviet crews couldn't match. German engineers had absorbed the lesson from that muddy roadside near Mtsensk and answered it with steel, optics, and firepower. But speed came at a cost. The Panther was rushed into service far too quickly. When it made its combat debut at the Battle of Kursk in July 1943, mechanical failures plagued the new tanks almost immediately. Engines overheated. Transmissions failed under strain. Some Panthers broke down before they ever reached the front line, victims of a production schedule that had outpaced proper testing. Crews who had trained for weeks on a machine still riddled with flaws now faced Soviet gunners in the largest tank battle the world had ever seen. Yet despite this brutal debut, the design itself endured. Later production models ironed out many of the early mechanical problems, and the Panther went on to earn a reputation as one of the most effective tanks of the war, feared by Allied crews on the Western Front, respected even by the Soviets whose own machine had inspired it. It's a strange, almost uncomfortable irony of history. The tank that would become a symbol of German engineering excellence was born not from innovation alone, but from fear, from a single afternoon near Mtsensk, when German soldiers stood in the rain and realized their enemy had built something better. War has always forced this kind of reckoning. Ideas cross battle lines faster than borders ever could. Enemies learn from each other, sometimes in the space of a single shattered convoy, and the machines that follow carry pieces of both sides forged together under pressure. Today, restored Panthers and T-34s sit quietly in museums, sometimes only a few rooms apart, sharing space that their crews could never have imagined sharing back in 1941. Visitors walk past both without always knowing the story that connects them, a story that began with mud, rain, and one captured tank on a forgotten road outside Mtsensk. If you'd been a German engineer standing over that captured T-34 in the rain, what would you have done differently? Let me know in the comments. And if you want more stories where a single battlefield discovery reshaped the course of the war, make sure you're subscribed.